As we know, there are 5 sampling techniques. In this video, we will explore this online random number generator and also the random number generator by Excel. After we use this sampling technique to get the 10 data out of 50, then we will put this 10 data into a graphing calculator, fill out this table, and then figure out the linear regression line using this formula. First of all, I will show you use Excel to do the random number generator. I already label all my data as index 1 to index 50. Then you click on one cell, get the 10 rows. So click here and make all borders. Then you click on the first cell, double click, put the equal sign, type rand. Then you could see this is 3. Click on rand between. Then you will do from 1, 50, parentheses back, then enter. You will get the first random number. Then click this cell again, find this plus sign, drop down, so that you can get the 10 random number given by Excel. Another random number generator from stat track. So they ask you how many random numbers you need. I put the 10. The minimum value, I will put the 1. Maximum value is 50. Then this one asks you allow duplicate entries. We cannot have duplicate entries. So you just put the false, then calculate. When you scroll down, they will give you 10 random numbers from 1 through 50. I will use this 10 random number to choose the sample. So according to the random number given by online random number generated, I got this 10 data. I will put this 10 data into a graphing calculator now. Now I already put those 10 data into the stat. Then I will go back to stat, then do calculate. Go to second one, 2 variable stats, then put the enter. L1, L2, yes. Now we don't have a frequency list here. So just do the equation. Then you will get 2 variable stats. If you move the arrow down, you can get the stats for variable y. As sub x called the sample standard deviation. This is a standard deviation. When we use the formula given this one to figure out the linear regression line, remember the formula they write down as sub x basically means standard deviation. Do not use this sample standard deviation. In other words, we got to use this sigma x to substitute as sub x, sigma y to substitute this as sub y. For these 2 variable stats, we can figure out the mean standard deviation, minimum value, and maximum value. But if you want to get a lower quartile, median, and upper quartile, you have to use 1 variable stats. So we will go to this stat again. Click calculate. Go to the first one variable stats. We will work on L1 first. Put the enter calculate. You will get the stats for the first variable. And they will show you this Q1, Q3 median, maximum, minimum. Then we can go to stat again, calculate. Still go to the first variable stats. This time, it's not L1. You will do second 2, that's L2. Then put the enter, enter, enter. So you will get the stats for the data in L2. Basically, that's the height. Also, from these two variable stats, we can figure out all kinds of summation notation, like sigma here. All this summation will be useful for you to figure out correlation coefficient. By graphing calculator, we figure out all kind of summation notation required for this correlation coefficient formula. Then we substitute into this correlation coefficient formula, we got the R equals 0.804. One more time to remind you that this S sub x, S sub y, basically from the graphing calculator, that's sigma x, sigma y. Then we figure out this correlation coefficient R is 0.804. We got X bar and a Y bar. We figure out this standard derivative for X and Y. We put into this equation. This is the linear regression line for this 10 data. But definitely you can get the correlation coefficient and the linear regression line from a graphing calculator. First of all, we quit and go to second 0 catalog. Try to find diagnostic on so that the graphing calculator can show you correlation coefficient R. Yeah, it's here. So we put the enter again. Then we go to stat, calculate. Go to 4. So press 4. Then enter. Just keep doing enter. So you could say you got a correlation coefficient R and also the linear regression equation.